So, all right, this first one, this is not really an ACT question. Now look at that very first one on your packet there. I'm going to switch it over. All right. All right, we just got a couple of 45, 45, 90s, and we have to find like a missing side. Did I have that on there? Okay, did I miss you? Did I miss? You got, okay. All right. Now, so let's see if y'all can figure it out. All right, there it's a 45, 45, 90. They give you one leg is 9. What's the hypotenuse? Yeah, 9 square root of 2, right? Remember the relationship? We take the leg and we multiply it by square root of 2. So the hypotenuse is 9 square root of 2. Now, one thing about 45, 45, 90s is you really don't have to know the relationships. You can always use the Pythagorean theorem. But if these two are the same, then these two sides are the same, right? So it's a right triangle, but it's also an isosceles triangle. So this one would be 9 also, right? Now, how else could I find the hypotenuse there? Yeah, 9 squared plus 9 squared equals h squared. You could have done it that way, okay? But this is really 45, 45, 90 is a shortcut of the Pythagorean theorem. Now, let's look at the B one down here. So it's 45, 45, 90, and they give you the hypotenuse. So how can we go backwards here? How can we go from the hypotenuse to the leg? Divide by what? Square root of 2. Okay. So that means this leg down here would be 8 divided by square root of 2. Now, more than likely, the ACT is probably not going to give something like that. It's probably going to be in a simple form. Why is that not simplified? Right. Can have a radical in the bottom. Okay, so we'd have to rationalize it. So we're going to multiply by square root of 2 over square root of 2. So that would be 8 square roots of 2 over 2. And then what's 8 over 2? 4. So that would be 4 square root of 2. What would my other leg be over here? 4 square roots of 2. Same thing. Okay. Now, let's go to some 30, 60, 90s. Now, I'm not going to do these. These are just kind of repeats. Let's take this triangle. Okay. So this one, you got, obviously here, 90 and then a 30. So the other one would have to be 60. Okay. Tell you what, let's do one. Let me do an easier one with you first. Okay. They give you the hypotenuse is 40. Let me give you one where the short leg is 40. Okay. It's always easy to start with a short leg. So let's call that 40. That'll be my 30. This will be my 60. All right. Let's find those two legs. The A and the C. Okay.
So for C is 80 and A is 40 is the 30.
Right. That's it. Okay. Now let's look at the relationships. Okay. So 40. Now I made the comment it's the short leg. How do I know it's the short leg? Right. It's across from 30. So the smallest angle is across from the smallest side. So that 40 has to be the short leg. And so A would be the long leg. So how do we go from the short leg to the long leg? You multiply by the square root of 3. Okay, this is an easier problem. So this one would just be 40 square root of 3. Now, how do I go from the short leg to the hypotenuse? Double it. So this one would just be 80. Okay. Now, let's look at number 12 though. This time, the 40, they put that on the hypotenuse. So one thing that you couldn't do here, it's really difficult to go from like the hypotenuse to the long leg. Okay, so you always center everything back to the short leg. Find the short leg first. Now, the short leg would be which one? The X. All right. So what's my relationship between my hypotenuse and my short leg? It's going to be half, right? So this would be 20. Now, what's the relationship between the short leg and the long leg? We'll multiply that by the square root of 3. So it'd be 20 square root of 3. Right? Now, so that one started you off with the hypotenuse. I started you off with the short leg on that one. Now, let me start you off with the long leg. Okay? So, here we go. Let's try this one. All right. Let's say that this one is 7. that's 30. Okay, let's find these two values here. Okay, so y'all see where the 7, all right, y'all understand how that would be the long leg? Okay, now, so we don't want to go to the hypotenuse. We want to go to the short leg, which is the E down there, because that's across from that 30. Now, so how do we go, let's do it this way. How do we go from here to here? You multiply by square root of 3. So if I go backwards, then I would divide by square root of 3. So this one would be 7 divided by square root of 3. Now, you probably need to rationalize that. Okay. So can y'all rationalize that in your head? So 7 square root of 3 over 3. Now, how do I go from the short leg to the hypotenuse? You double it. Okay. So if you double this, what would that be doubled? 14 square root of 3 over 3. That's the harder version of the question right there. Okay, so start with a long leg. So a lot of times when you start with a long leg, a lot of times it'll have like 7 square root of 3, so it's pretty simple. It's already in terms of square root of 3. Okay, you want to do one like that, or?
Yes.
Yeah? Okay. All right, here we go. Let's do one really, really simple. Okay, so let's put that as a 30. And this time, let's call this 10 square root of 3. Okay, so that's my long leg. All right, what would my short leg be then? 10, does that make sense? We divide by square root of 3, so the square root of 3 will go away. All right, does that make sense right there? 10. So you see what I'm saying? When it already has the square root of 3, it's pretty simple to see. It's just 10. Now, what would my hypotenuse be? How much? 20. That's it. All right. Now, let's start. We're going to do one more thing, and then we'll start with some. Now, on the ACT, look, it's not going to jump up and down and say, hey, everybody, look, it's a 30, 60, 90, or a 45, 45, 90. You're going to have to figure that part out. Okay? And once you get that part figured out, you can start working on it. Now, where you get, especially a 30, 60, 90, is when you draw an altitude of an equilateral triangle. I'm pretty sure that's not how you spell equilateral. I think it's got an I in there. All right. Now, so let me show you this, okay? So let's draw us an equilateral triangle. We'll talk about what the altitude is. So what do we mean by equilateral? All sides are the same and angles are the same too. Okay? So both sides are the same. Now, if all the angles are the same and they have to sum up to 180, what would they each have to be? 60, right? That's 60, that's 60, and that's 60. Now, what an altitude does, an altitude will measure the height for you. And a lot of times what you need that for is to find the area. Okay, you need the altitude of the height of the triangle. Now, so when I draw altitude, if I draw it from here to measure the height, only in an equilateral triangle is an altitude going to split it in half. Now, altitude is always going to be perpendicular in any triangle, but it'll split it in half there. So it splits these two sides in half, and it splits that angle in half. So what's going to happen to that angle there? They're going to split into what? 30 and 30. So, wait for it, 30, 60, 90. You get two 36, they're identical 30, 60, 90 triangles. They will be actually congruent to each other. Okay? And a lot of times the ACT will ask you about the area of a triangle, and you have to figure out that altitude. And by doing that, you just get a 30, 60, 90 triangle. Now, all right, let's jump off into some ACT questions here. All right. It says, what is the number of square units in the area of an isosceles triangle with a hypotenuse of 5 square root of 2? So let's draw this. And notice, it didn't say anything about 30, 60, 90 or 45, 45, 90, did it? But it said this. What did it say? An isosceles right triangle. Now, if it was an isosceles right triangle, that would mean that these two sides are the same, which means that these two angles would be the same. So if that's 90, these two have to be 90, and half of 90 is 45. So there you go, 45, 45, 90. So you had to figure that out. Now, it said that the hypotenuse was 5 squared root of 2. Okay? Now, let's find the area. All right, so now, for the area, so you got to know the area formula, or what would be cool if we had a program that would store the area of a triangle for us and other formulas, that would be awesome. Okay? And we could put it in our calculator and we could pull it up eventually. All right, but the area of a triangle, now I think that program says 1/2 base times height. Okay, so I learned it this way. It really doesn't matter. I learned it as base times height divided by 2. Either way, it's the same thing. Okay, so the base and the height, though, would be the legs, wouldn't it? Okay, so if my hypotenuse is 5 squared root of 2, and this is a 45, 45, 90, what are the legs going to be? 5. So that's 5. That's 5. Now, base times height divided by 2. So 5 times 5 divided by 2. So it'll be 25 divided by 2. What's 25 divided by 2? 12.5. Okay. And look, when you take the ACT, y'all don't have to write out 12.5. You don't have to show your work. Circle the answer. Okay. Don't do more than you have to. All right. Next one. Same question. Okay. An isosceles right triangle. What is that? What is that going to turn into? 45, 45, 90. Okay. So a 45, 45, 90 triangle. Okay. Let's draw it out real quick. 45, 45, 90. Has a perimeter of 20 plus 10 square root of 2. And they're asking the same question, what's the area of the triangle? Now, instead of telling me one side, they give me the perimeter. So this is kind of tricky. So what you have to do from the perimeter is you have to figure out a side. Okay, now think about this. What normally shows up on 45, 45, 90? What normally shows up on the hypotenuse? The square root of 2, right? So guess something here. What do you think the hypotenuse would be in this? It would be 10 square root of 2, wouldn't it? Okay. Now, I may be wrong about that, but I can check it. Okay. So let's say this is 10 square root of 2. Now, what would the other two legs be? 10. Okay, so this one would be 10, and this one would be 10. Now, let's make sure that's right. So would that give me a perimeter of 20 plus 10 square root of 2? Yeah, the 10 and the 10 would give me the 20, and so plus another 10 square root of 2. Now, what is the area of the triangle? So we just need to do what? Base times height divided by 2 again. Okay, so it would be 10 times 10 divided by 2. So that's 100 divided by 2. That would be 50. All right. Now think about this. You could not figure that out unless you knew your 45, 45, 90, could you? Okay. And look, most of the time, there's usually a 45, 45, 90 triangle on the ACT. Most of the time. About half the time, there's a 30, 60, 90. All right. Just FYI. Now, look at this one. All right. We talked about this a minute ago. An equilateral triangle. Okay. Equilateral triangle has an altitude of 10 square root of 3 units. So here we go. Here's my equilateral triangle. All it tells me is my altitude. Okay? So the altitude, that's that segment that's going to measure the height. Okay, so they're telling me it's 10 square root of 3. Okay? Now, I have to find the perimeter. Now, the good news is on an equilateral triangles, all sides are the same. The bad news is I don't know what any of the sides are. Okay, so I got to figure it out for this. Now, so let's use some stuff. Now, if this is an equilateral triangle, that's 60, that's 60, and then what happened to this 60? It got busted into 30 and 30. Okay, so now I have a, wait for it, 30, 60, 90 triangle. Okay, so you see you'd have to figure out the 30, 60, 90. It's not going to tell you that part. Now, So I got 10 square root of 3. Let's find something else using that. Now, I'm going to look at just one of the triangles, just one of the 30, 60, 90s, okay? And we could do this. What would this side be? And let's back up. What's the altitude of it? It's all right. But what part of it? We call it the what? What's the one across from the 60? The long leg. Okay. So that one's the long leg, and then this one down here would be the short leg. You know, not the whole thing, but only half of it. Okay. And then of course that's the hypotenuse. Okay. Now, you remember where I want to go? I want to go to the short leg. Okay. Now, how do we go from the short leg to the long leg? You multiply by square root of 3. Now, I'm not doing that. I'm going the other way. So I would divide by the square root of 3. Therefore, the short leg would just be 10. Does it make sense? You just divide by square root of 3. Okay. Now, so what am I looking for again? The perimeter, right? So what I just say, 10 times 3? No, it would be 20 times 3, right? And 6th period had a hard time seeing this one. But y'all see where the 20's coming from? See, this is 10 right here. So then this side would be 10 because it's identical. And so that's 20. And so since it's equilateral, the other two sides are 20. So you say 20, 20, and 20, or 20 times 3. And that would be 60. All right. All right, we're going to do this one last because well, I'm old. Just wait last. Here we go. All right, go to the next one. What number are we on, by the way? I lost my numbers. Number 5? Okay, thank you. All right. Now, this is the same thing. Okay. Same kind of problem. The numbers are a little bit harder in this one. All right. It says in this figure below, BD is an altitude of equilateral triangle ABC. BD is 8 units long. So they're telling me again what the height of the triangle is. Okay, now there again, it wants the perimeter of triangle ABC, and it tells you note that the altitude is perpendicular to the opposite side, so that would form a right angle. Now, here we go again. If this is equilateral, this is 60, and this is 60. And what's the altitude going to do? It's going to bust that into 30 and 30. It's also going to break that in half too, right? All right. So same thing as the last one. The altitude, the 8, that's the long leg, isn't it? Okay. So let's go from the long leg to the short leg. How did we do that? Divide by square root of 3. Okay. So that means my short leg is going to be 8 divided by square root of 3. Okay. Now you want to rationalize it. Okay. So this would be 8 square root of 3 over 3. Now that would be from here to here, right? Okay. Now what are we looking for? The perimeter. Now every side's the same, so is 8 square root of 3 over 3 one side? It's a half of a side. Okay, so that means what this side would be 8 square root of 3 over 3. So put it all together here. What would be 8 square root of 3 over 3 and 8 square root of 3 over 3? 16 square root of 6? No. Square root of 3 over 6? No. 3. What happens when we add radicals? The radicand stays the same. Same thing with fractions. What happens to the denominator? You get a common denominator and it stays the same. Now, so is that the perimeter? That's one side. How many sides we got? 4, yes. 4 sides in a, no, okay. 3 sides in a triangle. Now, y'all see a shortcut here? Instead of adding 3 of those together, let's multiply it by 3, and if you multiplied it by 3, that 3, what happened to it? Yeah. Okay. Be like that pizza I ate lunch yesterday. It goes away. Okay. All right. So that just leaves me with 16 square root of 3. All right. I'm glad I taught geometry. If I didn't teach geometry, I wouldn't know this for nothing. I'd have got it. Right. All right. One side of an equilateral triangle is 16 units. Find the area of a triangle. Let's draw a picture. All right. Here we go. Equilateral triangle. All right. One side of it is 16. So, of course, all sides would be 16. Okay. Now, we have to find the area. By God, I wish it would have asked for the perimeter. That would have been a lot easier, right? Been 48, right? Okay. But it asked for the area. What's the area? All right. So base times height divided by 2. Or you say 1/2 base times height. Okay, either way. Now, what's missing in all this? The height. And I can draw the height. What's the height called? An altitude. And an altitude is not only going to form a right angle to give me height, but it would split that in half. So this is going to be what now? 8 and 8. Okay. And then it's going to split this angle up in half, which was 60. So it's going to be 30 and 30. Of course, that's equilateral, so both of those are 60. So there's a 30, 60, 90 triangle. How about that? Now, so what's the 8 there? How could that help me find that's the short leg. And then the altitude would be the long leg. So how do we go from the short leg to the long leg? Multiply by square root of 3. All right, so my long leg here is going to be 8 square root of 3. Now, I am ready to get my area. Okay, base times height. What's my base? 16, not 8, right? Somebody want to say 8. I know it. All right, 16, the big triangle. Okay, so 16 times 8 square root of 3 over 2. Okay. Now, some people probably that's smarter than me said this last period. I think Emma said this last period. If you use that instead of 16, you could just say 8. So you would half the base and say 8 times 8 square root of 3 would be 64 square root of 3. That was a little smarter. However, I am like stuck in a rut with that formula. So, there's the work from last period. How about that? All right, so 16 times 8 square root of 3 would be 128 square root of 3. 16 times 8 is 128. And then 128 divided by 2 is 64. So 64 square root of 3. Did y'all follow that okay? All right. Now, here we go. Here's another one. Now, out of all the problems, this is the only one that says, hey, look at me, I'm a 30, 60, 90. It says it. Okay? So it gives me the perimeter of it, and it wants the area. Okay, so draw us a picture of it. There we go. So this would be my 30, because that's my short leg. This would be my 60. Now, so the thing is it doesn't give you a side, it tells you the perimeter. Okay? But here, this is kind of what we did earlier. Y'all remember, let's go back to this problem real quick. Where was it? Nope, too far. Y'all remember this one? Same kind of problem. Okay? Now, this one was a 45, 45, 90 though. So, y'all remember how we kind of figured out that the 10 square root of 2 would have to go on the hypotenuse? Because the hypotenuse usually had something square root of 2 on it. Okay. What are we going to do with this one? Kind of similar. All right. The 10 square root of 3. Where did the square root of 3 usually end up being? On the long leg, right? Okay. So, this is probably right here. The long leg, which would be this one, would be probably 10 square root of 3. Now, if I'm wrong, I can adjust it. Okay, I'm just kind of guessing right now. So, if that one's 10 square root of 3, what's the short leg down here? 10. That's what it said. All right, and then what's my hypotenuse? 20. Now, see if the perimeter would be that it says. Okay, 10 and 20 would be 30, and so you get 30 plus 10 square root of 3. See how I kind of figured that out? Okay, I had to use a little bit of guessing right there, but I got it. Now, what's the area? All right, well, that's just base times height divided by 2. Here we go. Base times the height divided by 2. Okay, so 10 times 10 square root of 3 would be 100 square root of 3. All right, and then 100 square root of 3 divided by 2 would be 50 square root of 3. Doesn't it make you feel good when you get the answer and you actually see it as a choice? You feel like you got it right. Oh man, I got this one. Then you work it out and that's not a choice. You're like, oh crap, I'm screwed. All right, now here we go. This one's a little bit different. No more altitudes. Okay. All right, find the area of this rectangle. Now, how do we find the area of a rectangle? All right, we can look it up in our formulas. All right, length times width. Okay. So, we just take the length and the width and multiply them together. What's the length and the width? It didn't tell me. Well, darn them. Screw you, ACT. You want me to find the area of a rectangle, you need to give me the length and the width, by God. All right, now we got to figure it out. Now, they did give me this 8 right here, which is not helpful. No, it actually does help. Okay. Now, so notice this, though. They told me that angle down there was 30. Now, we should know because it's a rectangle that that one has to be 90, and then this one would have to be 60. There again, it's not going to scream at you. It's a 30, 60, 90. You're going to have to figure it out. Now, that's the 8 is the hypotenuse, right? Okay. So let's go with the short leg. Which one's the short leg? The left or the bottom?
The left.
Left. That's right. Okay. So what would be the short leg here then? 4? Yeah, that's right. So remember what the short leg is, half of the hypotenuse? Or take the short leg and double it to get the hypotenuse. Okay. Now, so I got the length or the width. I got one of them. Let's get the other one. Now the other one would be the long leg. Okay. So the long leg, we just take the short leg and multiply it by square root of 3. So it'd be 4 square root of 3. Now I'm ready to find the area. Okay. So the length times the width, right? 4 times 4 square root of 3 would be 16 square root of 3. Ken, you didn't see that.
See what? It's gonna be in the video.
Yeah, I guess you could pause it. It's not working anyway. Alright. Okay, this one's actually pretty easy. Alright. It says the circle in the following figure has a center C and a radius of 5. Right. What is the length of chord EF? F of this chord. I'm going to call that X. Okay. Now, so I'm going to find that. Now, it said the radius was 5. Which radius? All of them. Because all radii are congruent, right? They're all the same. So they're all 5. 5. Everybody gets a 5. High 5. Okay. Now, so what are we looking at? 45, 45, 90, right? Because these two are the same, so those angles are the same, so they're both 45s. So what's my chord there, my hypotenuse? Yeah, 5 square root of 2. That was really easy. Now, you didn't really have to know the 45, 45, 90 because you got a right triangle there, right? And both legs are 5. How could I have figured it out another way? Yeah, Pythagorean theorem. 5 squared plus 5 squared equals x squared. Okay. All right. Let's do this one. This one's pretty similar. It's just backwards. All right. The circle in the figure has a center C and a chord EF. That effing chord again. All right. And it has a length of 15 units. Okay. All right. Says what is the length of the radius R? Okay, so here's R. So how am I going to find that radius with that 15 way up there? Well, wouldn't the other radiuses be the same? Okay, so these radiuses would also be R, wouldn't it? Hey, you know you really say that, right? More than one radius, you'd say radii. Okay, so those radii would be the same. Now, since those are the same, am I looking at it again? 45, 45, 90. Okay, 45, 45, 90. Now, how do we get the legs, though, when we go backwards from the hypotenuse? You divide by square root of 2. Okay, so this would be 15 divided by square root of 2. All right. That's not over there. I must have got it wrong. Well, I just got a rational. Okay, so this would be what? 15 square root of 2 over 2. Oh, bam, it was cat. All right. All right, this one's fun. Somebody want to come up here and do it while I take a break? Been doing this all day. All right. I'll let y'all do one in a minute. Okay. All right, I'm gonna sit down and say goodbye. Okay. In this, we got a right circular cylinder. Okay, I think everybody knows what a cylinder is. With points C and O. Okay, are centers of the bases, so they're the centers of the circles. XY measures 8 units, and it's the diameter of one of the bases. Okay, so it's the diameter. So let's go ahead and just label this. This is 8. Now that would make CX and CY the radii. So that means what do those do? What's CX and, yeah, 4. All right, may not help me, but it's there. All right. Now, here's the good part. Triangle XYO is equilateral. Okay, so that means what? Each side of that triangle would measure how much there? 8. Okay, see it? So each, what? This would be 8, and then this would be 8. Okay. Now, it says, what is the measure of the triangle's area in square units? Well, area is just base times height divided by 2. What do I need then? The height, okay, which would be this altitude, right? So here we go for like the 5th time. The altitude in the equilateral triangle, it's going to split stuff up. It's going to split this angle right here into 30 and 30. Of course, that would be my 60 because it's an equilateral triangle. Okay, so let's see. We need the height. Now the height would be the short leg or the long leg? Look at it. The long leg. Okay, so the long leg is across from the 60. Okay, so this is my long leg. Okay, I don't have long legs. Now, the short leg is 4, isn't it? Okay, so what's going to be my long leg? 4 square root of 3. Now I'm ready to find my area. Okay, so base times height divided by 2. Now base is not 4. 4 was just the short leg. The base is actually 8. So it'll be 8 times the height, 4 square root of 3 over 2. Right, so that would be 32. 8 times 4 is 32. So 32 square root of 3 over 2. And 32 over 2 would be 16. So that would be 16 square root of 3.
Can you just do half a base times 4?
Yeah. So you could have just, like, you're using the formula 1/2 base times height, so the base times height divided by 2, and it's faster. That way you get to just say 4 times 4 square root of 3, and certainly that's better. Is that what you kind of said? Yeah. Yeah, that's fine. Okay. So that's the thing about the area of a triangle. You can go ahead and half the base. We already half the base, and it was 4. Okay. All right. Y'all figured that one out. That one's easy. Got a song for this one. No, it's not that. Near, far, wherever you are. That's the Titanic. There's Jack down there. He's dead. There was so room on that door for both of them. All right, this was pretty simple. Okay, now this one, doesn't scream 30, 60, 90, but hey, 90, 60, 30. Okay, so if this one's 30, what's this here? The short leg. Okay, and so this one would be the long leg. So we take the short leg and we multiply it by square root of 3. So this one's 500 square root of 3. Okay, that was pretty easy. Now, what would the hypotenuse be?
1,000.
Yeah, 1,000. Okay. All right, this one's not hard, and we'll sit down for this one too. All right. Okay, square ABCD, shown below, has side length 5 meters. Okay. Now, if it's a square, all sides are 5 meters. Okay. The square is divided into 25 non-overlapping congruent squares. That's really not important for this question. It says point P is the center of ABCD. Okay. Now, first one, there was actually 3 questions that went along with this. I just took one of them. Okay. That's why they told you all this other information. What is the length in meters of AC? Now, think about what would AC sort of represent here. It would be the hypotenuse. And so if this one was 5, and then this one down here was also 5, it would be a 45, 45, 90. Okay? So then the hypotenuse would be, C, 5 square roots of 2. Okay? All right. Now, let's go back to this booger. This one's the worst. Okay. Now, let me walk you through this. I want you to work part of it first, okay? All right. What is this, by the way? What number? You'll find that one for me. 4. Okay. Right triangles 1 and 2, so that's just like triangle senior and triangle junior, are similar figures. Now, similar means that their angles are congruent, but their corresponding sides would be proportional. So a lot of times I hear y'all say, that they're the same shape, but they're different sizes. Okay. Now, just for reference, what happens in this one is triangle 2 is bigger. Okay. Doesn't really matter. Now, it says the angles in triangle 1 are in a ratio of 1 to 2 to 3. Now, I've already taught you about how to take a problem and do with that. So that means what? One angle is not 1, and one angle is 2, and one angle is 3, but it's 1 times something, 2 times something, and 3 times something. So instead of something, we're going to say x. So we're going to say 1x, 2x, and 3x. Those are the angles of that triangle. Now, what should they sum up to? 180, right? So what's 1x, 2x, and 3x? Not 6. Somebody can't add up here. All right, that'd be 6x, right? So you get right down 6x equals 180. So x would be what? 30. Okay. So 1x would be 30, 2x would be 60, and 3x would be, wait for it, 90. Okay. 30, 60, 90 triangle. Now, that would have been a lot better if that had just told me it was a 30, 69 triangle. Okay. Now, if the perimeter of triangle 1 is 15 plus 5 square roots of 3, and the shortest side of triangle 2 is 15, what is the perimeter of triangle 2? Well, crap, I don't know. All right, let's draw it and figure it out. Okay, so draw your 30, 69.
One interruption. Students that ride bus 101 need to ride bus 344 today to the junior high. Once you get to the junior high, you will get on bus 101 at the junior high. Thank you.
All right, there we go. Okay, now, so I got two 30, 60, 90 triangles. Let me put my angles in here. right, now, we did a problem like this earlier. It gives me the perimeter. It doesn't give me the sides. So it says that the perimeter of triangle 1 is 15 plus 5 square root of 3. Where's that 5 square root of 3 going to go? On the long leg, so here? Yeah, so that would be 5 square root of 3. The short leg would be 5. And the hypotenuse would be 10. Okay. Now what was 15? The shortest side of triangle 2 is 15. Now y'all see how why I drew it bigger? Obviously it's bigger. Okay. Now, what's the perimeter of triangle 2? Well, we need to figure out those sides. Now this is just a similar triangle problem. Okay. So all you have to do is find the similarity ratio. What's the similarity ratio? That means what do you multiply to get from here to here? 3. Make sense? 3. Okay. So what? Use that. What's this side going to be? 15 square root of 3. And then use this. This one would be 30. Let's get the perimeter. 30 and 15 would be 45. And then plus 15 square root of 3. Question?
Yeah, I didn't do any of that. That's about.
That's cool. There's lots of ways to do it. All right. So I think another way you could have done that was figure this out. This was 5 and this was 15. So you could just take this and multiply it by 3. There's about 4 different ways to do that. Okay. Yeah, that's true. I didn't have to figure all this. Yeah, all I had to do was take this 15. Duh. And you could have found that and that without finding all this. Okay. Yeah, I did that facility. I still got it right. Okay. I didn't do it the best way. That's right.